Let's go straight into the math. So we're going to talk about solving quadratics by factoring. And if we remember, factoring is really just breaking up an expression into numbers or other expressions that can be multiplied to get the original expression. For example, let's take the number 12. And I said, all right, let's factor it. Well, we can think of, all right, well, we know 4 times 3 is equal to 12. But that's not completely factored because while the 3 is good, the 4 can still be broken down. It can still be factored even more. So we take, all right, well, what can multiply to get 4? We know that's going to be 2 times 2. So if we see that 2 times 2 times 3 is equal to 12, then 2, 2, and 3 are the factors of 12. All right, so if we were to take now a look at example 1, and let's ignore that equals 0. Let's just say we wanted to factor it. Okay, so if we just wanted to factor example 1 and said, all right, what's a number, what are terms that go into both 8x and 6, right? It has to go into both of them. Well, I know that it's even. So if we know it's even, then we know they're both divisible by 2. All right, so if we take 8x divided by 2, it's going to give us 4. And if we take 6 divided by 2, that's going to give us 3. But look at that, we still have an x there. So we have 4x. 6 divided by 2 is 3. Okay, but what did we take out? What did we divide out? We divided out a 2. So if you think about factoring, this is a really important point. If you think about factoring as just the opposite of distribution, then that's a really nice, easy way to think about it, right? Think about it like, well, the opposite of addition is subtraction, opposite of multiplication is division, opposite of distribution is factoring. Okay, let's take a look now at this example number 2. All right, this time we are going to solve. So let's take a look at 10x squared minus 15x set equal to 0. Well, if we take 10x squared and 15, well, they're both divisible by 5. So we can take a 5 out for sure. What else can we take out? Well, and by take out, I mean factor. What else can we factor out? Well, that has an x squared. That has an x. So x squared and x. We know that there's a minimum of one x between them, all right? So we can take out an x. We can factor that x out. When we factor it out, think about dividing it out of each term. So 10 divided by 5 is 2. X squared divided by x, well, if we're just, again, think about dividing out an x, there's going to be one x remaining. All right, let's look at that 15x. 15 divided by 5 is 3. If there's a single x here, divided by another x here, well, there's no more x's left over, so we're done there, and set equals 0. Now we're going to talk about what's called the zero product property, which you should know. Zero product property. Zero product property just means if you have something that's factored, and this expression is equal to 0, we'll just set each of those factors also equal to 0. So we're just going to take 5x, set that equal to 0. We're going to take 2x minus 3, set that equal to 0. All right, 5 times a number. 5 times a number is equal to 0. Well, that number has to be 0. So x is equal to 0. Now, if we take 2x minus 3, we can add that 3. So 2x equals 3. Well, divide by 2, and you now get x equals 3 divided by 2. Okay, 3 divided by 2. We can leave it as a fraction. There you go. All right. So x equals 0 and x equals 3 over 2. A lot of times for these quadratic equations, well, look, there's going to be a squared. A lot of times that tells you there's a possibility that there's going to be two answers, two solutions. All right, not always, and we'll get to later on. We'll get to what that means here as well. All right, let's take a look now at example 3. All right, well, this is already factored, but this is kind of leading to another point. So if this is already factored, well, let's say, okay, we're going to multiply, right? I said distribution is the opposite of factoring. Let's see what this looks like. So if we multiply, we take x times x is x squared. X times negative 3 is negative 3x. 7 times x is plus 7x. And then 7 times negative 3 is negative 21. All right, combine like terms in the middle. We have negative 3 plus 7 minus 21. All right, there you go. All right, so now let's kind of go in the other way. So instead of factoring, you're multiplying. All right, And if I'm going too fast, feel free to pause. Notes should be available online as well. They should be available in a packet of some sort as well. So if going too fast, just feel free to pause, rewind, do what you got to do. All right, example 4. So we have x squared minus 3x equals 28. So we noticed in the previous problems, they were all equal to 0. This isn't equal to 0, but what we have to do is get it equal to 0. So let's go ahead and subtract that 28 to both sides. Okay, so if we subtract that 28, that goes to 0 because 28 minus 28 is 0. Left side, this is our result. Okay, so now let's go ahead and factor. When we factor, we want to do, I'm sure you've seen this before, there's a big X. All it is just a way to organize our ideas. Okay, so let's organize it. You should know that we're going to take, all right, well, what are two numbers that multiply to get this last term, negative 28? Get rid of that. So two numbers that multiply to get this negative 28, and two numbers that multiply to get negative 3, that middle number, negative 3. All right, well, let's do some brainstorming here. I know I'm not going to go through my whole thought process. I know that negative 7 and positive 4 are going to work. All right, hopefully this is just a review, but negative 7 and positive 4 are going to work. All right, so we know that those are going to be our factors. So we're going to take x minus 7, x plus 4 equals 0. We still have that 0. All right. One way you can double check, just multiply it back out again. You should get the same exact thing. All right, so let's use the zero product property, set each factor equal to 0. And then this is easy enough. Take the inverse, we add 7, we get a plus 7. Okay, we subtract 4, we get a negative 4. And that's it. Okay, you can always double check, plug it back in. That should give you a pretty good idea of what your answer is supposed to be. Moving on to example 5. This one's a little bit different. Okay, the reason this is a little bit different is because now our a value, the term in front, or the coefficient in front of that x squared, is actually something other than 3. Okay, so here are some steps if you don't remember. Number 1, multiply a and c. Now a and c are the first and the last terms, okay, the 3 and the 4. So number 2, use some organization technique. We're going to use that big X to factor, okay? And then number 3, we're going to factor by grouping. Okay, there you go. So first, number 1, multiply a and c. We're going to put this in our big X. A times c, 3 times 4. 3 times 4 is 12. That's the number we're trying to multiply to get. And our middle number is negative 8. Okay. Now, what are two numbers that multiply to a positive 12 but add to get a negative 8? Something interesting is happening here. Since this 8 is negative and this 12 is positive, well, we know since that 12 is positive, then both of our numbers have to be the same sign. So that tells us that has to be negative. That has to be negative because our 8 is a negative. Two negatives, when you add together, get even more negative. Okay, so, well, two numbers that multiply to 12, 6 and 2. It might take a little bit more trial and error if you're not quite there yet, but you'll get there if you just the more problems you do. Okay, negative 6 times negative 2, positive 12. Add them together, you get negative 8. All right, so here's the factoring by grouping part. Let's do that. We take 3x squared. That's just our original problem now. So our original problem, 3x squared, and our last one is plus 4. What we did here is we broke up this negative 8x. When we break this up, we say, all right, well, we know it's negative 6x minus 2x. Well, that's going to be the same as negative 8x. Okay, we just broke up that middle term into something that's going to be factorable. All right, so factoring by grouping takes this first group and this second group. Those are two binomials now that we can actually factor. All right, so if we take 3x squared minus 6x, we say, all right, what are two numbers, or what's a term that's going to factor out here? Well, we see, okay, well, 3 goes into both of those. So 3 goes into both of those. And we know that an x also goes into both of those. You see they both have an x. All right, if we factor that out, we take 3, well, there's just an x there if you divide that. 6 divided by 3 is 2. X here, the x's divide out. Okay, there you go. And now we have negative 2x plus 4 that we can factor. All right, well, we see 2 and 4. So we can take out, since that's a negative, let's take out a negative. All right, so we're going to take out a negative 2. When we divide that out, we're going to divide, all right, well, that's just an x that's left over. And then 4 divided by negative 2, that's going to be a negative 2. All right. All right, again, this is still equal to 0. Don't forget that either. Okay, look at this. So now we see that this is really interesting. Every single time when it's factorable, you'll see something like this. Okay, so you'll see that whatever is left within these parentheses should be the same. This is essentially double factoring. Right? You know, sometimes we can call it double distribution. This is double factoring. Right? You can take out and factor, refactor, I guess, this x minus 2 out. So let's take out an x minus 2. Right? We see that there's an x minus 2 here, x minus 2 here. Well, let's look. We have a 3x and we have a negative 2. That's going to be what is left over. Right? Look at that. So we have x minus 2 and 3x minus 2 as our two factors. All right, what we do, quick and easy, set them equal to 0. All right, we see we're going to get x equals positive 2. Use some inverse operations. X equals 2 over 3. There we go. All right. So you might need a little bit more practice with that if that's not super comfortable, but we'll get there. It's a pretty easy process once you get the hang of it. Okay. Let's take a look now at number 6. So number 6 looks a little bit harder than maybe it actually is. We're going to simplify it a little bit more. Again, first thing we always want to do is to make sure that it equals a 0. So we're going to get that 12 over, cancel it out right here. That's going to equal 0. Look at that. Okay, let me make that a little bit neater. Okay. Now, something interesting is happening here. You could just factor it right off the bat and say, all right, I'm going to factor the way we just did for example 5. But let's work smart, not hard. What we have to do is say, all right, 2, 10, 12. Well, they're all even. So we can factor out a 2. That's called a GCF. Okay? A GCF is just something that all numbers in your expression share. In this case, they all share 2 as a multiple. So we're going to divide out a 2. When we divide out a 2, we're left with x squared. 10 divided by 2 is 5. And then 12 divided by 2 is 6. Okay. Well, now we just have to factor whatever's in the parentheses, x squared plus 5x plus 6. So we can just factor like normal. I think it was like number 3 or 4. Okay. So let's factor like normal. We're going to multiply to get 6, add to get 5. Pretty easy. 2 and 3. Right. Positive 2 and a positive 3. That should work pretty easily. All right. Look at this. That's going to tell us x plus 2 is one of our factors. X plus 3 is another one of our factors. Set that equal to 0. All right. We only care about the factors with an x in it because if it has x, that means we can solve. So you don't really care about that 2 when you're solving. All right. So we have x plus 2 equals 0. X plus 3 equals 0, which then gives us our solutions. Okay. There we go. So number one thing you got to do, find that GCF. Make your life easier. Don't think too hard about it. All right, let's go ahead and summarize this a little bit. So, summary. Always factor GCF when possible, just like what we did with number 6. Especially if the numbers are bigger, you might see, okay, is there something that we can factor out of this expression? Second thing, when solving a quadratic by factoring, make sure the expression is always set equal to 0 first. If it's not set equal to 0, then you just can't solve it yet. So you got to make sure it's set equal to 0. That's kind of the key thing when factoring.